Close your eyes. I want you to listen. Imagine a rhythmic, heavy sound, the roar of water crashing against rocks, the hiss of foam absorbing into dark sand. You can smell the salt and the moisture. Above your head, the wind rushes past, driving clouds across a pale sky. It sounds like the coast of Iceland or Hawaii. It sounds like home. Now, open your eyes. The sound is gone. The water is gone. Instead of a salty breeze, there is thin air, 95% carbon dioxide. Instead of clouds, a pink, dusty haze. The temperature is minus 60 degrees Celsius, radiation capable of killing a human in a matter of months. A silence so dense it presses against your ears. You are standing in the exact same place, the same coordinates, the same planet. You're just late. You are 3.5 billion years late. Welcome to Utopia Planitia, the largest impact basin in the solar system and, perhaps, the most critical location in the history of the search for extraterrestrial life. For decades, we have looked at the red planet and asked the same question. Was there water here? Not just ice on the polar caps, not just underground slush, but real liquid water on the surface. We found dried-up riverbeds. We found clay that only forms in wet environments. We found pebbles rounded by currents. But all these findings were like puzzle pieces that didn't fit into a coherent picture. Scientists argued until they were hoarse. Were these temporary floods? Puddles that dried up in 100 years? Or was this a real, stable world with a hydrosphere? We were missing the main piece of evidence. We were missing a line in the sand. If there was an ocean on Mars, it had to have a shore, a place where water met land, where tides and waves day after day, millennium after millennium, carved the stone. That doesn't just vanish without a trace. Geology remembers everything. And now, after half a century of searching, we have finally found it. Not NASA, not the European Space Agency. The answer came from a six-wheeled geologist named Zhurong, a Chinese rover that landed where others feared to go and saw what we had missed. It found a coastline. It photographed rocks shaped by waves. It drilled into the soil and found traces of tides. This discovery doesn't just change a chapter in the astronomy textbook. It rewrites the whole book, because an ocean means stability. Stability means time. And time is exactly what life needs to take its first breath. But to understand why this discovery makes scientists tremble, with a mix of awe and terror, we need to rewind time. Back to the days when we thought Mars was not just habitable, but inhabited by engineers building canals to save their dying world. We have always seen on Mars what we wanted to see, and the history of our illusions is almost as interesting as the reality we have just uncovered. In the late 19th century, Mars was not dead. In the imagination of humanity, it was old, wise, and desperately fighting for survival. It all started with a mistranslation. Italian astronomer Giovanni Schiaparelli pointed his telescope at the red disk and saw lines. He called them canali. In Italian, this simply means natural channels or grooves. But the English-speaking world, hungry for sensation, translated this word as canals, artificial structures. American wealthy heir and amateur astronomer Percival Lowell seized upon this idea with the obsession of a fanatic. In his observatory in Arizona, he spent nights staring at the trembling image of the planet. His brain connected random spots into clear geometric lines. Lowell drew complex maps of a Martian civilization. He told us a tragic story. An ancient race of Martians dying of thirst. Their oceans had dried up. In a last-ditch effort to save themselves, they built a giant network of irrigation canals to pump water from the icy polar caps to the equator. It was a beautiful, sad fairy tale. It inspired H.G. Wells to write The War of the Worlds. We looked at the sky and felt that somewhere in the dark, someone was looking back at us. And then came July 1965. NASA's Mariner 4 spacecraft flew past Mars. For the first time in history, we had eyes in orbit. At the Jet Propulsion Laboratory, engineers waited for the images with tension thick enough to cut with a knife. Data transmission was agonizingly slow, just a few bits per second. When the first image finally developed, silence fell over the room. No cities, no canals, no vegetation, not even water. The grainy black and white photos showed a world battered by craters. It looked like our moon, a dead, sterile piece of rock hanging in a vacuum. Newspapers came out with headlines that broke the heart of an entire generation. Mars is dead. Lowell hadn't seen canals. He had seen the reflection of his own blood vessels on his retina, amplified by fatigue and the desire to believe. Mars turned out to be a desert, sterilized by ultraviolet light. 10 years later, in 1976, the Viking landers touched down on the surface. They sent back the first color panoramas, rusty red rocks under a pale pink sky. Beautiful, but lifeless. Vikings' biological experiments gave contradictory results. First, a violent reaction looking like microbial respiration, then silence. Scientists decided it was just unusual soil chemistry, oxidizers burning up any organics. We resigned ourselves. We accepted the fact that we are alone in the solar system. The scientific community shifted its attention to other targets. Mars became an archive of dust. But here's the interesting part. Mariner 4 photographed only 1% of the planet's surface. The Vikings landed in 2 specific spots. We were judging an entire planet by peering through a keyhole. The Mariner images killed the dream, but they hid a detail that we only started to notice 50 years later when we finally had high-resolution maps. We were looking at the craters, but we weren't noticing what was between them. We saw holes from impacts, but ignored the strange, smooth curves of the landscape that neither wind nor volcanoes could have created. In the early 2000s, NASA changed tactics. Instead of searching for life itself, which is equivalent to finding a needle in a planet-sized haystack, they decided to look for the haystack. They asked a simple question: what does life need on Earth? Answer: liquid water. The new mantra was, follow the water. In January 2004, 2 twin robots, Spirit and Opportunity, bounced onto Mars in cocoons of airbags. They weren't biologists, they were geologists. Their instruments were designed to read history written in stone, and Opportunity hit the jackpot almost immediately. It landed in a small crater called Eagle. When it opened its cameras, scientists on Earth saw something strange. The surface was littered with thousands of tiny spherical beads. They looked like spilled scattered shot or blueberries in a muffin. NASA actually called them that, blueberries. Chemical analysis showed they were hematite, a mineral that on Earth often forms in the presence of groundwater. This was the first solid proof. Water was here. It soaked these rocks like a sponge. Years later, Curiosity, a rover the size of an SUV, descended onto the planet. It landed in Gale Crater and found something that made geologists weep with joy. Gravel. Ordinary, smooth, rounded stones. Think about how such a stone is formed. If you smash a rock with a hammer, the shards are sharp. To make a stone round, you have to roll it. For a long time. Kilometers and kilometers along a stream bed. Curiosity found an ancient riverbed. We could calculate the speed of the current by the size of the stones, about 1 meter per second, depth, knee-high. Imagine that. You could have stood there 3 billion years ago and water would have washed over your boots. Clear, cool, fresh water. Case closed, right? Mars was wet, period. But then a problem arose, a problem of scale and time. Everything the rovers found was local. Here, a stream. There, wet clay. Here, groundwater. Skeptics asked a fair question: what if these were just episodic events? Imagine a huge asteroid crashing into Mars. Ice melts. Lakes form for 100 or 200 years. Then everything freezes again. Is 100 years enough for life to originate? Unlikely. Evolution needs millions of years of stability. We didn't just need wet sand. We needed an ocean. A global, deep, eternal ocean. It was like trying to assemble a puzzle of 1,000 pieces while holding only 3. And frankly, 2 of them looked like they came from a different box. Because every time geologists said, "Look, there was water here," astrophysicists pulled out their calculators, frowned, and said, "That's impossible." We had evidence of the crime: gravel, clay, riverbeds. But we didn't have the murder weapon. Moreover, the prime suspect, the sun, had a perfect alibi. Here is the core of the problem. It's not just a difficult puzzle. It is a paradox that has kept astrophysicists awake at night for 40 years. Stars are not born perfect. Like people, they change with age. Our sun today is a powerful, stable reactor. But 4 billion years ago, when Mars was supposed to be warm and wet, our sun was an infant. Models of stellar evolution tell us with absolute certainty, the young sun was dim. It shone 30% weaker than it does today. Let's apply this to Mars. The planet is 1.5 times further from the sun than Earth. Even today, with the current bright sun, the average temperature on Mars is -60 degrees. That is colder than Antarctica in winter. Now, dim the light bulb by 1/3. By all laws of physics, ancient Mars couldn't have been a resort with oceans. It should have been a frozen hell, a snowball planet, a white frozen sphere where the temperature rarely rose above -80. In such an environment, water is as hard as granite. It doesn't flow, it doesn't carve rocks, it doesn't form clay. And here we hit a wall. On one side of the table sit the geologists. They lay out photos of pebbles, riverbeds, and minerals. They say, look, water was liquid. This is a fact recorded in stone. We cannot argue with reality. On the other side sit the climatologists and astrophysicists. They show their equations. They say, there isn't enough energy. The water must have frozen. Your reality is impossible. One of them is wrong. Scientists tried to salvage the situation. They came up with the greenhouse blanket theory. They hypothesized that the atmosphere of Mars was incredibly dense, full of carbon dioxide and hydrogen, that it worked like a down jacket, trapping the meager heat from the weak sun. It's a beautiful theory. But there is a problem. If the atmosphere was that dense, where did it go? To create such an effect, you need pressure several times higher than Earth's. Today, the pressure on Mars is less than 1% of Earth's. Where did trillions of tons of gas vanish? Blown away by the wind, locked into rocks? The numbers didn't add up. Others proposed the idea of an ice world with a hot heart, that oceans existed under a crust of ice, heated by volcanoes from below. But curiosity found traces of rain and surface rivers. Rain doesn't fall under ice. Mathematics said, water is impossible. Geology screamed, water was here. Someone was lying. Or, what is even scarier, we were missing a fundamental piece of information. We needed to stop reading tea leaves in Gale Crater. We needed to go to the place where, in theory, the very heart of this impossible ocean should have been. We needed to go to the bottom. And for that, we needed a new player. Someone who would look at the problem with fresh eyes and new technology. In May 2021, a new ship approached the orbit of Mars. It didn't bear the NASA flag. It was the Tianwen-1 mission of the China National Space Administration. Inside the protective capsule slept a rover. Engineers named it Zhurong. In Chinese mythology, this is the god of fire. The name was chosen deliberately. The god of fire was flying to ignite the spark of knowledge on a cold, dead planet. But where do you land such a messenger? Selecting a landing site is always a compromise between safety and science. NASA engineers usually choose craters where layers of sedimentary rock are visible. But the Chinese team chose a different direction. They aimed for Utopia Planitia. Utopia is a strange place. If you look at an elevation map of Mars, you see that the planet is literally split in two. The southern hemisphere is high, crater-pitted mountains. The northern hemisphere is a smooth lowland lying several kilometers below sea level. Utopia Planitia is right there. It is a giant bowl, the largest recognized impact basin in the solar system. If there was ever water on Mars, it inevitably must have drained there. Gravity leaves no choice. Utopia is a planetary bathtub. If an ocean existed, its bottom is right here. Landing on Mars is always a lottery with death. The atmosphere is too thin to rely solely on parachutes, but thick enough to burn up a ship upon entry. You have 7 minutes to drop your speed from 20,000 kilometers per hour to 0. And the signal takes 10 minutes to reach Earth. That means when you on Earth receive the signal atmospheric entry, the rover is already either safely standing on the surface or is turned into a pile of smoking metal. The computer must do everything itself. On May 15th, The capsule entered the atmosphere. The heat shield glowed red. The parachute deployed, the thrusters fired, and the god of fire gently touched the dust. China became the second nation in history to successfully land a rover and begin operations. Zhurong is different from its American cousins. It is smaller, but it has an ace up its sleeve, a ground-penetrating radar capable of seeing through the Earth to a depth of 100 meters. Curiosity and perseverance scratched the surface, studying chemistry. Zhurong can see the planet's skeleton. It drove south, slowly, carefully. The landscape around was dreary, an endless flat plain littered with small stones. It seemed there was nothing to look at here. Viking 2 landed here in 1976 and found nothing but boredom. But Zhurong's mission wasn't to find beautiful rocks. Its mission was geographical. Scientists suspected that somewhere here, the ancient coastline must run, the boundary where the Great Northern Ocean met the land. If the models were correct, Zhurong had to cross this invisible line. Unlike other rovers searching for signs of microbes, Zhurong wasn't looking for life. It was looking for the edge. It was looking for the place where the land ended and the abyss began. And when it started transmitting data from its radar and cameras, the boring plane suddenly began to speak. The ground beneath the rover's wheels started to change. The structures it saw couldn't have been created by wind. They couldn't have been created by volcanoes. The rover drove straight into the surf zone. When the images from Zhurong's cameras landed on the desks of scientists in Beijing, they saw something that didn't fit the picture of an ordinary desert. The rover was moving through terrain dotted with strange structures. These were cones, small mounds with pits at the top, looking like miniature volcanoes. But they didn't erupt lava. We know these structures on Earth. You can see them in Azerbaijan or Yellowstone. They are mud volcanoes. They form when an underground mixture of water, gas, and soil is under pressure and bursts to the surface. The presence of a mud volcano on Mars tells us one critically important thing. There was liquid slush. Not ice, not steam, but liquid mud that bubbled and splashed. But that was just the beginning. As the rover advanced north, toward the center of the plane, the soil beneath its wheels began to change its pattern. It became polygonal. Imagine a dried-up lakebed in Death Valley. The ground cracked into regular polygons, like giant tiling. In geology, such cracks are a signature of water. They arise from wetting and drying cycles. The ground swells when water comes, and shrinks, cracking when it leaves. This couldn't happen at the bottom of a deep ocean where water stands constantly. And it doesn't happen in a dry desert. It happens in only one place, the coastal zone, where the water level constantly fluctuates. We were looking at traces of tides, but the most convincing proof was hidden underground. Zhurong's radar X-rayed the soil to a depth of 100 meters and revealed the structure of the layers. If you slice a sand dune created by wind, the layers of sand inside lie a certain way. But what Zhurong saw was different. The layers were tilted toward the lowland. They were stacked on top of each other in sheets, like a deck of cards pushed to one side. Geologists call this progradation. It happens when water carries sand to the shore and dumps it, gradually building land out toward the sea. This is exactly how river deltas and beaches grow on Earth. The rover effectively drew us a map. First, it drove on old land. Then, it crossed a zone furrowed with channels where water broke through the shore. And finally, it drove out onto the seabed. The data formed a unified picture. Scientists were able to draw a line. Here was water, and here was land. This line stretches for thousands of kilometers, hugging the entire northern pole of Mars. But amidst these peaceful proofs of lapping waves, the rover found something frightening. Huge boulders scattered where they shouldn't be. They lay amidst fine sand like toys thrown by a petulant child. This isn't just mud. It is the frozen echo of a catastrophe. Geologists believe these boulders are witnesses to a mega tsunami. Imagine an asteroid crashing into the ocean. A wave 300 meters high rushes toward the shore, tearing off cliffs, grinding stones, and throwing them far inland. When the water recedes, these boulders remain lying there as monuments to chaos. This discovery adds a dark shade to our pastoral picture. The Martian Ocean wasn't a quiet resort. It was a violent, dangerous place where tides alternated with cosmic-scale disasters. And yet, Now we know for sure. The ocean was there. Jurong gave us proof we can touch. Now that the stage is set and proven, we can allow ourselves some boldness. We can close our eyes and try to see this world as it really was, not through dry radar charts, but through the eyes of a living being. Let's forget about rovers, charts, and spectral analysis for a minute. Let's transport ourselves there physically. Wipe the red dust off your monitor. Imagine we are standing on that very coastline Jurong found, but 3 billion years ago. The first thing you notice is the air. It is dense. It presses on your shoulders. Today, the atmosphere of Mars is a vacuum by Earth standards. But back then, it was thick, saturated with carbon dioxide and water vapor. The sky overhead isn't pink or black. It is pale, perhaps gray-blue because of the clouds stretching from horizon to horizon. It is raining. Try to comprehend this fact. On a planet that today is the symbol of drought, a fine, cold rain is falling. Drops tap against dark basalt rocks, running into streams that rush down to the great northern ocean. Before you is an endless expanse of water. Utopia Planitia is flooded. The water is cold, probably around 0 degrees, but it doesn't freeze due to salinity and pressure. Waves roll across the surface. They aren't as high as Earth storms, but they are rhythmic and persistent. The landscape looks alien. There is no greenery, not a blade of grass, not a tree, not moss. It is a world of 2 colors, black volcanic rock and blue water. The contrast is so sharp it cuts the eyes. The shore is empty and bleak like the coast of Iceland, but magnified to planetary scales. You inhale the air and your lungs fill with a strange smell. It doesn't smell like flowers or forests. It smells of wet dust, sulfur from distant volcanoes, and salt. If you walk to the water's edge, to where Jurong found its sedimentary layers, you see the tide. The water slowly advances on the land. Gravity does its work. The ocean breathes. Now look under your feet. In the shallow water, right by the shore, the rocks are covered with something slippery. This isn't algae in the sense we know. These are bacterial mats, slime. Colonies of simple organisms harnessing the dim light of the young sun to live. They are the only inhabitants of this world. It is quiet here. No bird calls, no rustling leaves. Only the sound of the wind and the endless rumble of waves rolling pebbles. The same pebbles that curiosity will find eons later. It was a harsh world, cold but alive. The potential for evolution was colossal. If you left this planet alone for a couple of billion years, this slime could have crawled onto land. Mars could have become a second Earth, or Earth, a second Mars. They were like twin brothers walking the same path. In this moment, standing on the shore of Utopia, watching the sunset where a small sun dips into the haze over the water, it seems to you that this ocean is eternal, that it will always be this way. But this is an illusion. In this idyll, a countdown timer was already ticking. Deep beneath your feet, thousands of kilometers down, the planet's heart was beginning to stop. Neither the bacteria in the water nor the waves on the surface knew their fate was already sealed. The protective dome that held the atmosphere and heat was preparing to vanish. The death of Mars didn't start on the surface, it started in the deep. Earth has an invisible bodyguard, the magnetic field. It is generated by the rotation of molten liquid iron in our planet's core. This giant magnetic bubble deflects the solar wind, a stream of charged particles flying from the sun at 1,000,000 kilometers per hour. As long as the dynamo in the center of Earth works, we are safe. Mars had this shield too. 4 billion years ago, its core was hot and liquid. The magnetic field protected the dense atmosphere and allowed the oceans to remain liquid. But Mars is smaller than Earth. It cools faster. At some point, a date we don't know exactly, the Martian heart grew cold. The iron currents in the core slowed and solidified. The dynamo stopped. The shield fell. In that moment, the sun turned from a giver of life into an executioner. The solar wind began to strike the planet's upper atmosphere unimpeded. It began to strip it away layer by layer, molecule by molecule, carrying it off into open space. This process is called sputtering. It was a slow murder. For millions of years, the wind ground down the sky. The pressure dropped. And what happens to water when pressure drops? It begins to boil, even at low temperatures. The ocean in Utopia started to evaporate not from heat, but because the air stopped pressing down on it. The water turned to steam, rose into the sky, where the solar wind tore the molecules apart and carried the hydrogen into space forever. The planet was drying out. The coastline Jurong found began to retreat. The ocean shrank into seas, seas into lakes, lakes into salty puddles. Those bacterial mats that lived by the shore ended up on dry land. They dried out and turned to dust. Mars became rusty. Oxygen from the water oxidized the iron in the soil. The blue planet turned red from shame and destruction. Scientists long thought that all the water flew off into space, but the math didn't add up again. The rate of atmospheric loss is too slow to explain the disappearance of an entire ocean hundreds of meters deep. Where did the rest go? The answer turned out to be even stranger. Mars didn't just evaporate, it drank its own ocean. When the volcanoes fell silent and the crust cooled, the rocks began to work like a giant sponge. The basalt absorbed the water, chemically binding it within its crystal lattice. The water turned into stone, into hydrated minerals. The ocean didn't vanish without a trace. A huge part of it, perhaps 30 to 90%, is still there. It's not in space. It is right under the rover's wheels, locked in a stone prison from which there is no escape. Today, Mars is a mummy, a perfectly preserved corpse of a planet that could have been a paradise. But for us humans, this graveyard is the most valuable gift in the universe. Because Jurong and its fellow rovers aren't just digging in a grave, they are drawing a map that could save us, and perhaps lead us to those who managed to hide before the end of the world. The discovery by the Jurong rover isn't just a checkmark in a scientific report, it is a turning point. Before this, we were wandering in the dark, stumbling over rocks and guessing what they meant. Now we have a map. We know exactly where the water boundary was, and on Earth, we know one rule: where water meets land, life thrives most vigorously. This means that future missions, whether robots or humans, will no longer be pointing at the sky. They will follow in Jurong's tracks. They will drive to this ancient coastline to drill deeper. If life existed on Mars, it didn't disappear overnight. Life is stubborn. When the surface became hell, it could have gone down into deep aquifers, into salty pockets where water remains liquid thanks to the heat of the depths. Perhaps, right now, as we speak, a kilometer beneath the dry red crust in absolute darkness, something living is still dividing its cells, waiting for the moment when conditions become suitable again. Or waiting for us. But Mars teaches us another lesson, a lesson in humility. Looking at the rusty deserts of Utopia, we are looking in a mirror. Mars and Earth started the same. Two warm, wet worlds, two sisters. But one got lucky and the other didn't. The difference between a blooming garden and a dead desert is just a few thousand degrees in the core and a bit of luck in the cosmic lottery. We are used to thinking that our blue planet is a constant, that the oceans are eternal and the sky will always be blue. Mars screams to us that this is not so. Planetary habitability is a fragile gift. It is a temporary state that can vanish due to cosmic chance or the fading of an inner fire. We are the only beings in the solar system capable of realizing this fragility. And we are the only ones who can appreciate the beauty of what was lost. At the beginning of the video, I asked you to close your eyes and imagine the sound of the surf. Now, a dead silence reigns over Utopia Planitia. The wind rolls dust across the bottom of a dried sea. The mud volcanoes sleep. The boulders brought by the tsunami have lain motionless for 3 billion years. But now, thanks to a small 6-wheeled robot, we know the truth. This silence is deceptive. If we listen to the data, if we read the history written in stone, we will hear that sound again. The ocean of Mars did not vanish without a trace. It continues to live in our knowledge of it. And as long as we keep searching, as long as we keep sending our ships into the dark, the waves of ancient Mars are still crashing against an invisible shore. We just had to learn how to see them.